Hello friends, this talk is on topic image processing techniques using MATLAB 2012. Image is pictorial data stored into computer in the forms of two-dimensional matrix, and when we manipulate the contents of that two-dimensional matrix, we may call it as image processing. Here in MATLAB, which is matrix laboratory language, gives the facility to process the image. Different operations we can perform on that image just to improve the quality, which will be further used by the user or applicant to extract the contents present into that. Sometimes we may also use the output of MATLAB for the automation application of computer system. For this content, reference book is Understanding MATLAB, which is published by Shrap Publication. Here we will see basically how to read and write the image data in MATLAB. Through reading process, we extract the content which are in pictorial form from storage device into MATLAB environment, and then we do further operations like display, or we may further modify the contents which are already read and save that modified content in different names, and further we may use it in the forms of modified output. To check the contents which has been modified, we can use the function name as imfinfo, which gives the details about the image which has been modified, which consists of the modified name, format which has been used to modify, like earlier it was PNG, after modification suppose we have made it as JPG, so the new modified format will appear. Then what is the version number of the file format, file modification date, and after modification what is the size, width, height, number of bits per pixel, and either it is of type true color, grayscale, or index image, etc. These information we can verify after modification as well as before modification. The first command which we are going to see is related to how to read the image from computer into MATLAB environment. The statement used to read it called imread. Syntax is imread in bracket name of the file. Here in place of name we can also put complete path from where we are going to read the image, which consists of driver name, directory name, subdirectory name, etc. And the output will stored into RGB. Now here RGB is the matrix variable holding all grayscale value of the image named as football.jpg. RGB is a variable like other programming languages. Further we can use it to process any type of operation. Once we have processed that data, we can further use imwrite to write the image, save back onto the storage device after modification. Another function we directly use to read the image which is present in the MATLAB environment, which is of type matfile, using function named as load. Load followed by simple file name. In imread function we have to specify extension also, but in case of matfile we need not have to write any extension. Directly load followed by its file name. In this case, the file whose name we have been specified get read and stored into MATLAB workspace area. From there we can use that variable, default variable where it has been stored, like in earlier case it was RGB, now here the default variable which support in MATLAB environment. Once we have read the image using load function, we can check the name, size, and other details of that image using function named as whos. It display the information like name of the file, its size, number of bytes occupied depends upon number of bits per pixel, a class is double, single, uint8, or uint16 etc. and other related attributes of the image. So using whose function we can check which image we have been read and what are the details of that. Then IAMWrite is the function used to store the modified image. Syntax consists of 3 parameters. X is the name of variable which we are going to write. Map consists of the grayscale pattern and then followed by the new name of the earlier file. In this case extension is BMP. We can give any possible support type of extension allowed in MATLAB. So we can change or it is rename of modified image. So we have IAMRead to read, IAMWrite to write the image after doing certain processing. Now come to the MATLAB environment where we will see different types of windows we have to process them. The main basic window we have over here is called command window, through which we execute all possible commands and functions. Then the data which has been processed in this command window, their details will be stored into workspace window. This is workspace window, and from workspace window we can directly select the variable which has been earlier modified or processed. Current folder gives the information about which folder is open, from where we are going to read the image, etc. Then we have one window called history, which maintains all the previously executed list of functions, and those list of functions we can recollect back using up and down arrow of the keyboard. And using that, what happened is we need not have to retype the function again, so we can save the time. We can also reduce the complexity might be arises while typing the function. Now let us start with the MATLAB environment. The first function is to read the image. Variable I am going to use over here is RGB, which is equal to IAMRead, as the function consists of syntax as in bracket under single quotation we have to put the name of the file. Suppose it is pout.tiff as the name of file, and here we must have to terminate the statement with semicolon. If we remove the semicolon, it display complete output of IAMRead on the command window itself. So to avoid that, we have to terminate it by semicolon. As soon as I press the enter key, pout.tiff image get read and stored into variable named as RGB. Now let us check what are the contents present under this. So function whose is used to verify the details about it. It is just like dir command of DOS function, DOS operating system. Name of variable where we have stored the image, size 291 by 240. It is number of rows and number of columns. Number of bytes total occupied are 69840, and the class type is uint8. It is unsigned integer 8-bit per pixel. This is detail about the image we can check. Now to write this image with different name, function we have is IAMWrite, and in bracket syntax consists of the variable name in which currently we have the image and followed by new name. Earlier it was map in the syntax, but map is optional. We can skip that map as optional variable also. Now suppose after modification I would like to put it as modified image. So I say modi and then pout dot png for example. Now I am going to change the extension of it. As soon as I press the enter key, it stored the modified output of the image. So we can write it using IAMRead and change the contents which are already there. So new contents we can put into a file. Now another case we will see as the function used to display the image. Here the function used to display the image is I am show, and with the variable in which we have read the image. So I am show with the variable in which we have stored it, it will display the figure into figure window. So this type of figure window will appear where it shows the image which we have been read earlier using I am read or either by load function. In this figure window we have different tools available to directly process over here, but now currently we will not see any one of the tools to directly manipulate on them. We will see different processing through MATLAB command itself. So we have I am show to display the image into the figure window. Now further I will read another more image. Say I as the variable name is equal to I am read, and now second image I am going to read is cameraman dot png it is, and then terminate the statement with semicolon. Okay, so extension of this cameraman is tip. Now we have two images currently available in the environment. Now let us check the details of both of them. So one image is in I variable, second one is in RGB variable. Now to show both of them we have to use the syntax called figure, comma, I am show, and then the second variable in which we have read cameraman.png. So by using figure.com, figure comma I am show, it is possible to display both the image at a time. If we remove figure comma I am show, then the new image which we are going to display will be overwrite on the previous figure which is present in the figure window. On the previous image it will overwrite, so only last image will show, earlier will be get overwritten. To avoid it, we have syntax called figure comma I am show and the new variable name. In this way we can display n number of image at a time. Every image can be displayed into different figure window, right? Now here to see all of them at the same time, the restriction is we have to manipulate both the window. We have to set the size of both the window as well as the location also if we wanted to see both of them at the same time. So to avoid this, we have statement called subplot. Using that subplot, we can display multiple images in single figure window. So what MATLAB will do? MATLAB will take multiple images together and put them in matrix format. While putting them into matrix format, it will decide the size and index number of that figure. Okay, so let us start with the subplot function. Subplot comma subplot in bracket, we have to specify the size of your figure window, how many amount of images we are going to put over there. So I say initially 2 by 2. We'll use to store 4 images and index number is 1. Outside the bracket say I am show, earlier image RGB, first image. We can give title also. Okay, so title with syntax title in single quotation. The first image was spout, and then say enter. To select the previous subplot window from history, just press upper arrow, so it will reappear the earlier command which has been recently executed. It will help me to simply modify the index number, then figure name, and get the image or execute the command with less number of efforts. Here now we have to put the new title, and the new image is cameraman. In this case, the figure window has appeared, which has been divided into 2 by 2 matrix, and with serially index number it is going to display those images. On serial number 1 and serial number 2 successively it has been displayed. Just let us see here. this type of output has been appear, where the first image, the whole figure window divided into 4 parts. On first index number, first image is there, on second image. In this way, here third and followed by fourth we can display. So serially row wise it will divide the figure window into row and column order and give the index number as 1, 2, 3, 4 like that. Same figure window we can also divide by 2 by 3 or 3 by 3 like that. When we divide it by 3 by 3, total 9 elements we can able to display at the same time in one figure window, where 3 rows will form and row number will start, index number will start with row as 1, 2, 3, second row 4, 5, 6, third row 7, 8, 9, etc. So here up till now we have displayed two images into figure window. Now let us see the histogram of that particular image. Here histogram is the plot in between grayscale value and the number of times grayscale value appearance. It is simply a plot in between them. So at third index number we are going to display the histogram. So I'll say I am hist as the histogram of first image initially, which is RGB, and title I say histogram of POUT. So it will display histogram of image named as POUT at index number 3. Similarly, to have the histogram of second image, just simply change the index number as 4, say I am hist of I, and now title is histogram of cameraman. So it will display histogram of my second image. Now earlier we were having only 2 images in that matrix. Now here along with 2 images we got histogram, respective histogram of those images. Here histogram is simply a plot of grayscale value against its count, indicate that how many times a particular grayscale value has appeared. For example, here if we take 100 as a grayscale number, it has appeared around 400 times. If we take another example of 155 grayscale value, we can say it is appear around 50 or something 55. So histogram will use to analyze the image, which type of pattern present in that particular image. Based on that, the image classified into 4 types: dark image, bright image, low contrast and high contrast image. Dark is the image where histogram lines present almost closer to origin, whereas in bright image the same vertical blue lines will appear at rightmost part of the histogram. In case of low contrast, it is appearing within the middle. So for example, this we can call it as example of low contrast. Where in case of high contrast, the complete band of histogram get covered by grayscale value. We can say it is equally distributed among a complete band of the histogram, and which is the most good quality image. So what we have to do is, based on histogram, we have to decide which type of operation need to process on this image to increase the visibility of that image, and try to convert low contrast, dark image as well as bright image into high contrast image. So now further we will shift to see how to process the image, how to improve the quality of this image. During improvement of quality, I'll take another new figure window. So to select the new figure window, we have to write figure comma and then another statement, say figure comma subplot. In that new size, like odd size 3 by 2, so 3 rows and 2 columns, and then index number first, where first we will show only the first image itself, then followed by title. then what we do the processing of this image to improve the quality. In this case, the new figure window is going to open with display of first image out of 6 at index number 1. Now in the same window we will show the histogram of it. At index number 2, say I am hist. So it is going to display histogram of it. Now here because of figure command was remain same, it has been appear in the new figure window. So while displaying we have to take that care also. When we say the first time and next successive image should be appear within the same window, so we have to remove the figure comma command. Otherwise it will again reopen the new figure window, and then the two images cannot be displayed within the same figure window. So this has now done, where the first image along with its histogram. It will help us to certainly compare the image immediately with its histogram. So gives us image followed by a pattern appear into that. Now let us do pre-processing. So J is equal to hist eq is the command used to do histogram equalization of the image which is recently read. So histogram equalization of RGB we will see, and output will stored into J. Now to display that newly modified image, say subplot at same size of 3x2 window but index number 3, where on index number 3 we will display the new modified image which is stored into J, and say it is enhanced pout image. So it will display the enhanced one. Now where along with the enhanced image will also display its histogram. So say at 4th index number display histogram of it. So I am hist of the J, it is histogram of enhanced image. It will help us to compare all these 4 images in single window. Now here we have 4 figures. This is the initial original image whose histogram indicate that it is of type low contrast quality, where because of all the grayscale present in between the range of 60 to around 170, and hence there is no balance between dark and bright pixel. So to make them balance, to have distribution of this grayscale value in complete band, histogram equalization is used, and it is simply stretching these grayscale value into complete band. So it is get distributed overall the image, and hence ultimately it gives the balance of dark as well as bright pixel. And if we compare this to, quality has been tremendously increased. The data which is not visible in the original part, which is currently visible over here, the small part also possible to visualize, and ultimately it will help us to increase the recognition rate, etc. So it is simple command used to do the improvement of quality. It is also called as pre-processing type of statement, and mathematically what it will do is it will check the probability of occurrence of grayscale value in that original image, and from that probability it decide what is the value need to be distributed commonly in complete pattern, and that value will get distributed. Ultimately it help us to increase the quality. So up till now we have seen to read and display the image, then read and display its histogram, followed by the histogram equalization technique to increase the quality of the image, and the output of that quality, enhanced quality, is measured in the forms of histogram. Histogram are the measurement process through which we can decide either really quality has been improved or not. Then we have some further statements which will be used to process the image, multiple images together. Command we have called as guide, through which we can create graphical user interface of the MATLAB, and which is like we have the front end back end type of technique used in Visual Basic, which will use to create certain interface where there are list of components we can place in the grid and then use to fire the query. So as we type a guide command, it is going to open graphical user interface. The first window appear after entering the command named as guide is to open either existing graphical user interface or create the new. Initially we'll say to create the blank one. So select blank GUI and say OK. It will open the new grid on the MATLAB. This is the grid where we are going to create the interface for the user. And now here on this particular window we have list of different commands, different components present over here. Each of them we can pick up and put into that grid. The first component is like push button, we have slider, radio button, checkbox, edit box, axis, etc. Currently we will see axis as the main component to display the image and push button as another component which is going to create the query for MATLAB. So here on this particular window, first put the axis. So say select, just enter or click on that and the cursor will appear in the forms of plus symbol. So hold the left button and then simply drag the mouse. So it will give us the effect of the axis. Axis component get added over here, and this axis will use to display image into that grid. Second component we are going to use is named as push button. So click and simply drag and drop. So it is going to display now. Second component named as push button. Initially when we tag a component as push button whose by default name is push button, if we required we can modify this label. To modify this, simply right click, select the property inspector. Under property inspector we will have different properties that we can modify and simply change the behavior of this particular command. Now here the label we can change of this button using property named as string. In front of string property we have default name called push button that we can change. So now I'll put it as read and show. So it is the command button used to read and show the image. As soon as I press the enter key, the new modified label will appear on that command button component. So now here command button component will help us to read and display the image into this axis. Previously we have displayed that image in figure window. Now here we are going to display that in grid and where we have a component called axis. Now to create the code, executable code of this called as query, we have to select the callback function of this particular component. Before going to selecting the callback, just let us save the grid which we have been created as the interface. So select file menu, say save. It will ask to enter the file of name of the file where we are going to save the interface. So the interface is read and show. So this is the name of interface, read and show. Say save. It will save into MATLAB bin directory. And now here Once we save, the another window will appear called editor of the MATLAB. This is the editor. It consists of the path as well as recently given name of the file, read and show.m. This editor consists of complete coding of template which we have been created as interface. For this interface, for the interface which we have been created, for this interface, the coding template is opened by MATLAB and it consists of list of function like list of function and required parameter to be passed to process the query which is fired by that component. Now here a lot of codes we have. It consists of all the basic properties followed by the information about the component which we have been entered. So instead of searching the particular component code template, what we have to do is come back to interface, select the button whose code we wanted to write, click right click and come to the option called view callback. Right click, say view callback. After view callback, we'll have certain different options. Out of them select callback. So it will help us to reach to a particular template of the component whose coding we are going to write. So here the name of function is push button 1 callback. Here we are going to write the code. Now the same code which we have been earlier written to read and show the image in command window, same thing we will write here to read those same images, just to show how we can create the interface. So here the image is pout.tiff and that we will store into I variable. Okay, so image will read and stored into I. Now to show that image into access component, we have to first focus the pointer onto that particular access component. To have it, the command named as access in bracket handles.access1. Handles.access1. Access1 is the name of our component and access is the function. So it will set the focus of your pointer to component named as access1. If there are multiple access present, then we must have to write this command. Then say I am show of I. Due to this, I will display into the access1 component. This is all about the coding which we need have to write as query for command button component. Now let us say save. So it will get saved. We can run this command by two ways, from this option or by clicking onto the figure window. Here we have the grid which we have been created. Here also the option we have. So we have two options, either pressing from the editor or from the figure window. So let us run first time from over here. As we run it, it will ask the certain settings like to change the path or to add the path. I'll select add the path along with the previously set path. Now here this is the interface. This is the interface created and consists of access component and the command component, command button component. Here we have to fire the query to read and display the image into this particular access. Let us press read and show button. As we click, image will read and display into this particular access. So this is more readable, more user friendly environment created, and as per the requirement we can put number of components together on this particular grid and have a good interface for the user. Now we will extend this interface for some more commands, like to have another command and one more access, just to increase the size or expand the size of it. Select second one more axis just to display the histogram of it. So here it will display now histogram, and we may take one more command button to say we wanted to have histogram also. So it will display now histogram using this particular command. To change the label of it, right click, select property inspector, come into string property and just change the new name. Default name is changed as histogram. Press enter key, new name will allocate it to the component. So in this way we can have n number of components over here. First will use to read and display, second one will use to read the histogram. Now to have the modified output of that image also, what I do, I simply put one more axis component over here, two more component, like first is used to read and display the image as well as histogram together using single button, and then histogram along with histogram equalization in the next button. Here one thing we have to remember is, as we are going to put the component named as axis, each newly selected axis is going to assign name like axis 1, axis 2, axis 3, axis 4. Meanwhile, if I delete any one of them, then the immediate number which we have been deleted will skip and new number will appear for the further new added axis component. Similarly, it has happened with the push button also. So what I do now, let us modify the original name of the first button. Earlier we had read and show. Now here along with that I'll show as histogram also. So read and show image with histogram, right? So read show with hist we can say. So it will read and display image along with histogram. Whereas for this button, let us modify using the same process of giving the name to the particular component. Now here instead of histogram we say histogram equalization. So two operations simultaneously we are going to do. Now what happened here, on first axis image will display, third axis its histogram, second axis modified image, fourth axis modified image histogram. Now let us say save. So it will save all recently added component template in earlier created editor. Now come to the figure window and let us modify the codes. So to reach to a particular code, right click on button, say view callback and select callback. Now it will reach to the routine function of push button 1. Here earlier we had read the image and show the image into that. Now the first axis 1 is remain same, but for displaying its histogram we are going to use axis number 3, this axis number 3. Hence certain modification required, which are like this, where we have to set the focus onto axis number 3. Set the focus onto axis number 3 and here say I am hist of I. So what happened is, here it read the image first, set the focus on axis number 1, display that image in axis number 1. Whereas after this the pointer will pass to axis number 3 and in that histogram of the pout.tiff image will display. So at top we have image, below that its particular histogram. Let us simply execute first this and further we will see the coding of second push button. So save, Now this time we are going to execute it from editor itself. So run the code. It has appeared like the previous one which was there. So we say read and show. Now what I do, just close down it, select the figure window which is here and say run. Now it is going to run as per the newly updated contents, consist of 4 axes and 2 command button. So code we have already put into the function body of it. Just click, so it will display the image and expected to display the histogram over here. But there are certain errors. Now come back to command window to verify which type of errors present over here. We can verify the error and then come back to editor where we had put the code. Now the first 2 lines were correct, where we have written read the image and display that into the command button. Now second thing is, when we try to write them into the second axis button, we have to set the focus into proper axis, then only it will pass the pointer. Earlier the error was in IAMHIST command. Now it is IAMHIST is the name of function. So simply save and execute. So it is going to run. Click the button. So it has displayed the image followed by its histogram. So image and then histogram. Here now it is expected to have quality improved image followed by its equivalent histogram. Now that coding is left. Now let us start to add that particular code. To add a code, we have to come back into the figure window of that interface. Right click on histogram equalization button, say view callback followed by callback. It will pass a pointer to the function body where the code we have to write. Now here, this time we will not going to read the image again. Instead of that, we'll take the image from axis itself, where already we have image in this axis. That same image we are going to manipulate. So no need to read it, reread it from the system. Instead of that, we can select directly from axis. So to get it into axis, syntax is variable is equal to say get image, and this image we have to get from the components named as handles.access1. Okay, so the contents currently present into access1 will read and stored into J. Syntax of get image is handles.access1. So in which component it is present, from there we can read. If it is in access4, so handles.access4, etc. Now let us improve the quality. So for improvement, hist eq function, histogram equalization, we have currently image in variable named as J. So image has been modified, quality get improved and stored into K. Let us display this in axis number 2. We have to display this over here and then followed by its respective histogram. While display them into proper axis component, we have to remember axis number. So come to the editor, and in that editor we will put now the proper axis number. So first thing is axis in bracket handles dot access 2, where the modified image we will display. So pointer will point to axis number 2, say I am show J. So modified image will display. Then axis in bracket handles dot access 2. Here in this case 4, 2 and 4 we have. Earlier in 1 and 3 we have already been displayed. Now 2 and 4 we have to utilize. So in editor type access in bracket handles.access2 to display the image after modification, and handles.access4, in that we will display its respective histogram. Say I am hist, where it will display in the axis number 4. So in axis number 2 image, and in axis number 4 the image. The image in which we have been modified after histogram equalization is variable k, so put that variable for showing the modified output. I am show to display the image, and I am his to display its histogram. Now let us say save after recently modification and rerun. Now here read and display is the output of first. Here expected is to have histogram equalized image and followed by its histogram. Let us close this, come to command where we have written. So get image handles.access1 to read the image, and then followed by histogram equalization hist eq, then access handles.access2 to set the focus. I am show for k, access handles.access4 to set the focus on to next image, and I am hist of k. While writing them into the proper access, we have to remember their name and then followed by the variable name also. When we put them into histogram equalization or histogram modification, we have to remember class also, which type of data is going to process over there. So what I do, first we say just to read the image which was earlier there in the first statement. So just read it using that same way and then do the processing of histogram equalization. So here histogram image will equalized, show into k and its histogram. Save and followed by run. Come to the figure window, say execute, read and show. So it will read and display the image along with its histogram. While displaying histogram equalization, earlier in previous figure the output was like this, where the input image get enhanced using the particular quality of the image. During histogram equalization, grayscale value has been modified. Here we expect to modify the same image and display into the interface which we have been created. Using this interface, it will help us to create certain applications, like we put the different components on that. We can create the menus on this particular editor. So in this figure window, along with like this command button, we can also put certain menus here. So menu bar also we can give list box, we can have certain text box, slider also we can put combo box. From there the list of different commands which are previously created, those we can provide and have to select those options from the same figure window. So using this we can build a good application through which it is possible to directly read the image from the any drive or directory and do certain processing as per the operations given into the slider, combo box, list box, or sometime the menu bar also. That type of interface we can create. So ultimately we can able to write a good application of a good interface of certain application using this graphical user interface. It is more useful to create different types of projects over here. Now along with this, in this interface up till now we have seen 4-5 commands just to read and show, but with 3 different ways. First way is to display the image into single figure window. Second time, have the multiple figure window into multiple images into one figure window. Then we have shifted to graphical user interface, where it is more friendly for the user to create the project or application. In that we can put multiple components together and create good interface for a particular application. So in this way there are different ways to process the image into MATLAB, and as per need we can process that image at different levels. Now here, along with processing, we have other different operations, like we can display an explorer using IamRead and IamShow. We have IamTool function which will similar like IamShow, but in addition to IamShow it also give different tools available in that figure window. Different tools are like, we say, to know the which type of grayscale value pattern present in that image while it is going to display into figure window. So as we simply say IamShow, it is appear in the particular figure window. IamShow can have different syntax, like we can put border with that particular figure window. So like here it has been appear in the forms of like IamShow, whereas this is the syntax with and without border type of. So if we put a border, it will looks more appearance will be change as compared to the normal figure window. So IamShow have different types of syntax while displaying that image onto the MATLAB figure window. Then using subplot, as we have seen different types of multiple images we can put over here in the same figure window, and it is processed like the simple array divided into the figure window divided into number of rows and columns. Now let us see the IamTool as another function which will help us to know the details about the image, and that details are, while displaying that image using IamTool, and as we move the cursor on the figure window, it gives current location. Like see here at the bottom we have pixel information, indicate that x and y coordinate and followed by what is the grayscale value of that particular coordinate. This type of functions will help us to know how grayscale value has been distributed in that particular image. This will help like to select the threshold value. Threshold value further we can utilize to do the segmentation of the image. So instead of going to the technique like to show the histogram and decide the operation, using IamTool directly we can decide which is the good threshold value used to segment the image into different parts. This IamTool also help to decide a main grayscale value which will convert the grayscale image into its binary. So it will work as boundary to divide image into one below that boundary as 0 pixel and above that boundary as pixel number 1. So we can convert grayscale value into binary equivalent by knowing which is the suitable boundary using IamTool function. Then we have some color map of that image. So while we read, it will also give the output in the forms of a color map. It consists of how grayscale value has been distributed, and it is used while displaying that into figure window. So in earlier case we had a command IamShow with IamWrite was the command with variable name followed by map and then the new name. So that same map we will get using the color map, and it will help to keep the original color distribution of the image, though we will modify that into the different image. Here some certain menu driven steps are there to process the image. Like we have a color map modification, say MATLAB color map function, so it will choose the color map. We have workspace variable, these are the radio buttons. As we select, it will select it and do the further processing. This type of interface also we can create in GUI or graphical user interface. This list box or radio buttons followed by command button, etc., and have the interface of the application good. Now to import the image data from workspace, as workspace is the window where all function which will execute, their output will stored in the forms of the variable. So from there we can directly select it into command window and do the further processing. We can also select the variable which are currently present in the workspace into the tools like Excel, where we import the total variable present in the workspace, call them into Excel, and we do further detailed analysis of that data into Excel sheet also. So we can interface MATLAB with the Excel, and there we give the more facility to process them, to have a plot of grayscale value, and just let us analyze which type of grayscale value present over there and how it has been distributed. So we can have interface of the MATLAB workspace with Microsoft Excel. We can have it interface with Microsoft Access while reading or importing set of images from the database. We can also export the modified output into Excel as well as Access. This is the area through which we can import the workspace. So here it gives now the list of variable, their size and the respective data types. If we simply double click, it will open into their respective editor, and if we say click and say import, it will get passed into the tool where we need to process them. And while working within the same environment, we can select them by simply drag and drop also. So while exporting image data to the workspace, we select the workspace variable, and at background we have to set the interface using certain menu driven step. Using them we can able to have interface with other environment and so on. So here while processing the images in the MATLAB, basic 4 or 5 ways are there. The first way is to process that into command window itself. Here a command window environment we have, in that we directly process. So at a time one image get processed initially. If you wanted to have multiple, we can go for the syntax like say figure comma and have the multiple images display into the single figure window, or we can go for to have multiple images together, we go for subplot. Further we can enhance or modify this capability using the next step called as creating the graphical user interface and have the multiple component together. So this is all about the basic process we can do in MATLAB of image processing. It will further used to have more advanced capability of MATLAB, like to do either spatial domain transformation or frequency domain transformation like TFT, DFT, etc., and have more processing into them. We can also use them to do the histogram equalization, etc. Here when we do the image processing into the MATLAB, the basic help which is available in MATLAB product can be more useful, while initially when we will be like a beginner. So to select the image toolbox, in help menu we have image processing toolbox, and under this at initial stage we have to go through the getting started option. Under this getting started option we have some number of initial process through which there are examples shown, as well as syntax is also there, and by following those methods steps we can easily learn the image processing toolbox present over here. Suppose for example, to read and export the image, we have read, display, and to check how it has been appear. All these list of steps are there which we have been recently seen. So the same step with example is given in the MATLAB help, and which is certainly directly useful for the beginner user. The same step which we have recently seen are given over here. To have more advanced steps, like once we will be more familiar with image import and export, we can go for image enhancement, through which the basic quality of the image get enhanced. Like here, the image is read and display, then certain morphological operations are performed to analyze the single image. Here the image is read and display, morphological operation to simply set or remove the foreground from the background, which is trell function to separate foreground from the background. Then further, the statement is used to display the content of the image in three-dimensional plot, and it gives how depth the grayscale value present in the image. We can subtract the foreground from background. As we subtract, the quality get improved. Now to increase further the visibility of the image, we use the statement called IAMAdjust, will use to select the dynamic threshold value and put the grayscale value and do the enhancement. Then we have gray thresh to select the good threshold value, further conversion into binary format. Now the next thing is how to identify the single object. Here statement is BW component, where BW followed by connectivity. This is 4 type of connectivity, and we check how many number of objects present over here. So in this case, number of objects are 95. So total 95 objects are appear over here. To examine any individual object, the thing is, in spite of extracting single object from there, we say we make false to all the object and simply true, make a true single one in which we are interested. So the pixel in which we are interested, whose index number we pass, and that pixel will make 1. Same example we can put for the application, like one group photograph is given, and from there it is expected to know or to only find out a single particular person. For such application, we can use this example where we used to simply show single person, or in this example pixel, other are hidden at background. And further we can know more statistical about it, like we can find the area, centroid, bounding box of it. Once we know the syntax, once we know the index number, we can directly process the individual pixel. Here in this particular example, out of total number of 95 grains, only single grain is shown whose size is minimum based on the area. So in this way we do the processing of images into MATLAB. With conclusion, this image processing is very much useful for processing the album, to create the images for internet application, or to do the enhancement of quality of the image, which will further used for automation of the system, like in quality control of certain industry, or the application like biometric fingerprint images or biomedical images. In that, to diagnose the diseases, we can use this basic operation of image processing, and it will helpful to have assistant for the doctors to do further correct diagnosis, etc. Thank you.